Welcome back, and this time we are going to look at functions graphically and just focus on the domain and range a little bit more there again. So if you remember, we want to talk about a function descriptively, that was with the definition. We want to talk about a function graphically, tabularly, and then also algebraically. Okay, so we're working on that. Okay, definition of function: every value of x, exactly one value, or I should say for every value of x, there's exactly one y. Super important, like box that, make that really big in your notes that it's super important. But then the question is, what does it look like on a graph? Okay, well, if we do a little bit of thinking here, we know that for each value of x, there's one value of y. So that means we have something like, let me do this in blue. Okay, we have something like that, and we have that, maybe up here, there, down here, up here. But what we cannot have happen is something like this. Okay, so this is a big no-no, because that means for a value of x, there are two values of y, which that can't happen. Okay, so so if you notice, well, two lines or two dots, you can make a line with it, right? That would be a vertical line, right? So if a vertical line intersects your graph of the relation in more than one place, it's not going to be a function. Okay, so the conclusion: any vertical line should intersect the graph of a function at most once. It could intersect no times, at most once. Okay, and some of us might know this by another name. This is called the vertical line test. So take a vertical line, and then it should pass through the function once or none. Okay, if it intersects twice, no good. Okay, so then really the punchline of all this, why do we care about this graphically? Classifying a relation as a function is super easy. You just look at a vertical line. If a vertical line intersects it twice, no go. Okay, but then what about domain and range? So here's that notorious function that we left off with at the end of the last video. So f of x equals absolute value of x. Now we haven't talked about the table form of a function yet, but table form really, it's not super insightful other than make an xy table. You can pick values of x and compute the values of y. I always like doing, say, -3, -2, -1, 0, 1, 2, and 3, something that's symmetric about the origin, just because wonky things can happen with negatives versus positives. And then if I look at the absolute value, and just remember that in this notation, f of x really is the same as y. So if I compute y by doing the absolute value, this is 3, 2, 1, 0, 1, 2, 3. Okay, and so that's the table form of this function. Surprise, surprise. And so then if we were to graph it, 0, 0, -1, 1, okay, here we go. I'm going to just kind of quickly sketch this. I would do a better sketch with more time, but you can get the idea here. So something like this. And so what it should look like is a nice solid V. Something like that. So then from here, this is why I like a graph of a function, because you can actually see the domain a lot more easily. So the domain is all set of first coordinates, right? And when we think about ordered pairs, that's x, y. So the question is, what values of x can I use here? Anything. And so you might have seen this symbol before. It just means all real numbers. Another way to express this in interval notation, again, you might have to review this, -infinity to infinity. Okay? And now the other thing, range, right? That's a set of all second coordinates, all y's, and so that one you can actually see visually here as well. The lowest value it ever will reach is 0, and it goes off or it goes only upwards from there. So we're looking vertically for range, what's our lowest and what's our highest. Domain, you're kind of looking left and right on a graph. And so range You have to do parentheses at infinity. You can never really reach it. It's a concept. But 0, you include it because you do have the value of 0 in there for a y value. So that's why you have to do a bracket. Okay, so there's that one. Now for this final example, I want you to pause the video, take a shot at it, tell me if it's a function or not first, and then take a shot at domain and range. Resume the video when you're ready. Here are the answers. It's not a function. So if you look particularly at this point, or when x is -2, you have a solid dot here, and then you have a line in the upper part here on this upper curve. And when you have a line, a line really is a sequence of infinitely many dots all smushed together. So you can put a dot wherever there is a line, a closed dot. And so here you would have a vertical line intersecting more than once. No, not good. Okay. Domain is all set of x values, right? So farthest left we go is to -5, and then this one's a little confusing. You end up going from -5 and you continue to progress right. So again, you violate the function property, whatever. You arrive at this next spot here, right? When x is 0, and it turns out at 0 you don't have a value of 0 here, but you do have one there, so that's okay. Press forward. Whenever you have a kind of a closed dot supersedes an open hole. Okay, and then you progress right, and that's why we go off to infinity. -4, same sort of thing. Now again, you're just looking vertically. So what's the smallest y value? -4. You progress up. Okay, you have 2 values here, and then you progress up. Now here again, you're looking at this one, looking horizontally now, and here on this part you have a line, so that means you have a dot there, so they end up closing each other, and you progress all the way to infinity. So functions, again, a little different in this last example. Maybe you have some questions, and let's talk about those in class. Bring questions to class. That is perfectly okay, and we can discuss those then. Other than that, domain and range are very important ideas to be able to see graphically and do graphically, but then function, remember, has to pass the vertical line test.